Greetings of the day. This is a course on regression analysis. In this course, we learn about what is regression analysis, why do we use regression analysis, and various types of regression analysis: linear, non-linear, simple, multiple. We also learn about regression curve, regression plane, and regression surfaces. Regression literally means stepping back towards the average. The term regression was first used by Francis Galton, a British biometrician, in connection with the height of parents and their offspring. Regression analysis attempts to establish the nature of the relationship between variables, that is, to study the functional relationship between the variables and thereby provide a mechanism for prediction or forecasting. This is the definition given by Yao-Lin Cho. If we see what is regression analysis, it is a mathematical measure of the average relationship between two or more variables. To establish the nature of relationship between variables, this is an important tool for modeling and analyzing data. It is a statistical tool with the help of which we are in position to estimate, that means to predict, the unknown value of one variable from the known value of the other variable. It is a form of predictive modeling technique which investigates the relationship between the dependent and the independent variable. Dependent variable we call as target also, and independent as predictor. Is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. For example, relationship between rash driving and the number of road accidents by a driver is studied through regression. Here we fit a curve, or we can say line, to the data points in such a manner that the differences between distances of data points from the curve or line is minimized. Why do we use regression analysis? Regression analysis estimates the relationship between two or more variables. We can understand this with example. Let's say we want to estimate growth in sales of a company based on the current economic conditions. You have the recent company data, which indicates that the growth in sales is around 2.5 times the growth in the economy. Using this insight, we can predict future sales of the company based on current and past information. There are multiple benefits of using regression analysis. It indicates the significant relationship between dependent variable and independent variable. It indicates the strength of impact of multiple independent variable on dependent variable. Significant relationship, strength of impact of multiple independent variable. It allows us to compare the effects of variable measured on different scales, such as effect of price changes and the number of promotional activities. These benefits help market researchers, data analysts, data scientists to eliminate and evaluate the best sets of variables to be used for building predictive models. If we see how many types of regression techniques do we have, there are various kinds available, but mostly driven by three matrices: number of independent variable, type of dependent variable, and shape of regression line. For the creative ones, you can even cook up new regression if you feel the need to use a combination of the parameters above which people haven't used before. Most commonly used regression: linear and non-linear regression, simple and multiple linear regression. First, we learn about what is linear regression. It is one of the most widely known modeling techniques. In this technique, the dependent variable is continuous. Independent variable can be continuous or discrete, and nature of regression line is linear. The variable which is used to predict the value of variable of interest is called independent or explanatory variable, and the variable which are trying to predict is called dependent variable or explained variable. Linear regression establishes the relationship between dependent and one or more independent variable using a best fit straight line, also known as regression line. It is represented by an equation where A is an intercept, B is the slope of the line, E is the error term. This equation can be used to predict the value of target variable based on the predictor values. By creating the best fit line for all data points in two variable system, value of y can be predicted from known values of x. So this is the curve, these are the data points. We want to try to fix this line. We want to make it best fit to all data so that it average out the deviation, or we can say error, minimize the error. Non-linear regression. The regression lines are derived under the assumption the variable x and y are linearly related. In many practical applications, this assumption may not be valid. Then, instead of regression, a curvilinear regression like second degree parabola, cubic curve, or exponential curve may explain the variability of the dependent variable y in a more suitable way. The best fit curve is derived using principle of least square. Now we see simple and multiple linear regression. The difference between simple linear regression and multiple linear regression is that multiple linear regression has more than one independent variable, whereas simple linear regression has only one independent variable. The analysis used is called simple because there is one predictor or independent variable, and linear because of assumed linear relationship between the dependent and independent variable. So the equation of the form AB are constant used to describe average relationship that exists between two variables. Multiple linear regression, the case where the dependent variable is a function of two or more linear independent variables. In majority of practical problems, the value of one variable may be influenced by many others. Whenever we are interested in studying the joint effect of a group of variables upon a variable not included in that group, the problem is called multiple regression. If the variable in bivariate distribution are related, then the points in the scatter diagram will converge around some curve called curve of regression. If y is to be estimated from x by means of some equation, we call the equation of regression equation y on x, and the corresponding curve regression curve of y on x. In case of regression curve is a straight line, then the corresponding regression is said to be linear, and the line is called line of regression. What is regression plane? Let be the three variable x1, x2 and x3. Then the equation of plane of regression of x1 on x2 and x3 is x1 is equal to a plus bx2 plus cx3, where a, b, c are constant. So 3 variables are there, so we are having regression plane. But if there are more than 3 variables, generalization to more variables involving linear or non-linear equation leading to regression surfaces in 3 or higher dimensional spaces which are easily made. Thank you.